Does the wheel spins while it travels? Sounds a stupid question, but not at all if you just animate with Path Constraint in 3ds Max. Today, in 3ds Max, we will animate a wheel using Path Constraint and a calculated approach for spinning of the wheel. First, make sure that feet-inch is selected as display unit in Unit Setup. We will look at the size of the wheel in a while. Now, go to Edit, Transform Toolbox. Click on Get in the Transform Toolbox. The size of the wheels is shown for its X, Y, and Z axis. The wheel has 2 feet on its X axis, 6 inches on Y axis, and 2 feet in Z axis. That means the diameter of our wheel is 2 feet. Keep a note of this diameter. We will need it in a while. To calculate the circumference of the wheel, click the Time Configuration button. We will make the wheel travel for 10 seconds, so we need to set the duration accordingly in the Time Configuration dialog box. We will now draw a path with a length of 100 feet, which will our wheel go through. Go to Top Viewport to draw the line. There is no parameter called length for a line object under the modifier panel. For now, delete the line. Move the wheel a bit through Y-axis. Go to Utilities panel. Choose Measure and click the button called New Floater. Now you will be able to see the length of the line in the measurement floater box while you draw the line. Enable Line Tool again, choose the drag type as Smooth so that you can have a curved line while drawing the line. We will now draw a line starting from the center of the viewport. And also have a look at the length in the measurement floater box. Continue drawing the line till you see a length of 100 feet shown by the measurement floater. Finally, we have drawn a line with 100 feet of length. That will our wheel travel through. Close the measurement floater. Let's give a name to the line. We will call it wheel_travel_path. We have not saved the scene for a while. It is a good idea to save as the scene with a new name. Select the wheel, go to Perspective Viewport. Assign Path Constraint animation to the wheel. Play the animation to see if the wheel goes through path. Pause the animation and go to the top viewport. The wheel goes on the path, but is not oriented correctly. Turn on the Follow option in the Motion panel. Now it following the path correctly. For the sake of comfort for calculating the wheel's required spinning angle, switch to the generic unit. Select the path, and go to the Utility panel. Measure Utility is still active. 100 feet is shown in generic unit. 1 system unit represents 1 inch. And 1 feet equals 12 inches. So, 100 feet is shown as 1200 generic unit. If you select the wheel and check the Transform Toolbox, you will see the wheel's X, Y, and Z dimensions are shown in generic units now. For calculating the wheel's total spinning angle, we will not use a calculator. Rather, 3ds Max has a built-in Max script listener through which we can calculate the spinning. We know that a wheel's circumference equals its diameter multiplied by pi. Wheel's diameter equals 24 unit, so wheel circumference will be 24 multiplied by pi. In the listener window, type 24 asterisk pi. So we got the circumference as 75 point something. We need the length of the wheel's travel path. Select the line. Go to the measure utility. Path length is approximately 1200 unit. A wheel travels a distance equal to its circumference when it spins for once. So in order to know how many times it spins while traveling its path, we need to divide the full path's length by wheel's circumference. Simple math. Path length / wheel's circumference. In the listener window, type path length divided by wheel's circumference. So our wheel spins around 15 times. That is 15.9317 times. When spins once, a wheel spins by 360-degree angle. So the total angle it spins, 15.9317 multiplied by 360 degree. Type accordingly in Max Script Listener window and copy the resulted value of total angle in degree. That is 5,735.41. To see what is the local spinning axis of the wheel, select the wheel, enable the Rotate tool, choose Local Reference Coordinate System. Choose Use Pivot Point Center. Then rotate around the spinning axis. Notice that the axis is Y. Turn on Auto key and go to the end of animation. And rotate the wheel around Y-axis a bit. This will be almost impossible to rotate using Gizmo at the 5,735.41 degree that we got a while ago. So we will take help of Curve Editor. Turn off the Auto key. Right-click on the selected wheel and choose Curve Editor from the quad menu. In Curve Editor, choose Y Rotation Track from the left pane. Select the End key and right-click on it. In the Value field, paste that total angle we copied from the listener window and press Enter. Close the Wheel Y Rotation box. Minimize or close the Curve Editor. Play the animation OT Scrub the timeline to see whether the wheel is spinning correctly. It does so, but since our wheel has a flat color, we may not see the rotation properly. If you do not see the spinning clearly, do a temporary trick. Create a cube on a face of the wheel and link it to the wheel. Then play the animation. Let's make a road that can actually be rendered. Clone the line and follow as demonstrated.